Hello, everyone. We're going to look at how we might create and evaluate expressions that we can use for everyday life. I'm going to start by looking at a problem right out of our textbook. It's one I really actually quite like because it's actually very realistic. Um, Colin is helping to organize a school trip to Ottawa. He needs to figure out the cost of transportation and choose the least expensive bus company. A total of 260 students are going on the trip. He has prices from 3 bus companies for the cost of 7 buses. He's got 3 choices here: the Carry-All Bus Company, the School Bus Company, and the Zim Transport Company. What he's got to do is look at each of these different cost scenarios and figure out what's the best one. Now, there's some things we need to keep in mind before we go ahead. So, first thing we need to keep in mind is he would like to find the least expensive bus company. Maybe not the best, but definitely he wants the least expensive. We know that 260 students are going. That number is probably going to be significant in at least some of our expressions. So we need to look for that. And we need to remember that he's looking for 7 buses. He's obviously figured out 7 buses will carry the 260 students. So let's look at the first one. We're going to go ahead and look at the Carry-All Bus Company right here. Okay, so the Carry-All Bus Company charges $350 per bus. In this question, in this particular scenario, the number of students is not important because we're only being charged per bus. And that number is going to stay the same. So that $350 is going to be the same no matter how many buses they take. Okay, so the expression might be 350 times B for bus. Okay, 350 times B. Okay, and written correctly, that would be 350 B. Okay, so 350B is what we need. Now we know the number of buses we need. We need 7 buses. So what that's going to mean in this particular situation is our equation is going to look like 350 multiplied by 7. And that's going to equal $2,450. So for the Carry-All Bus Company, right here, we are going to be charged $2,450. Okay, so now he's got to compare that against the other one. So let's go ahead and check a different one. In the second scenario for the School Bus Transport Company, they're actually charging $7 per student. So in this case, the actual bus number doesn't really come into play. They're not charging us per bus. They want to charge us per number of students that's going on the bus. So it's $7 per student. So $7 is the constant. They're always going to charge us $7, but we don't know how many students that is. So we might show this as 7 times S for student. Okay, and once again, correctly, it would be $7, 7S. Okay, that's how it would look. Now we know that there are 260 students. So to do this problem correctly, we would actually be writing $7 times 260, and that would equal only $1,820. So fairly significant saving from the other company. Finally, let's look at the Zim Transport Company, and they have a very interesting scenario where they're going to give us $500 to cover the cost of the drivers plus $6 per student. So in real life, this probably looks like a $6 charge per student, and then they want to make sure they take $500 to cover the cost of the drivers. Whether we have a lot of students or a few students, then they'll still get that $500 for their drivers. So how does this look? This is a little more complicated. So let's take a look at how we could write this one out. We would need to go with $500. That doesn't change. That's a constant. And we would need to look at $6 per student. So I'm going to fast forward and make that 6S since we saw 7S in the last scenario. So what are we going to do with these two? I know I'm going to have $500 plus, it's a little hint right here in the question, plus $6 per student. Yep, that's it. 500 plus 6S. Normally, mathematically, we'd actually arrange this. So we'd change it to $6 S plus $500. You can do that, of course, because it's addition. We can rearrange it. And then we would simply plug in our answer. So it would be our number of students. So 6 times 260. And of course, I have to add the $500 at the end. And that is going to equal, it's going to equal $1,560 plus $500. And the final cost is going to be $2,060. So we had all our costs, they all worked out. This one, it looks like the least expensive cost is going to be the one for school bus transport company, which was $1,800, I believe, or just around there. So using these different expressions, Colin was able to figure out which would be the best bet for his dollar. So now I'm going to give you a couple scenarios and present you with the opportunity to solve them. So let's look at this first one that I'm sharing with you. A person named Sam gets a job working downtown at the mall. He makes $14 per hour. That's probably going to be important. And he also has to pay, listen carefully, he has to pay himself $6 per day for his transit fare going to and from work, which means that every day he makes a certain amount of money, but he's got to remember that out of that money is going to come $6 per day for that amount. So we're looking for an expression for his daily salary. How much would he make in any given day? And the amount he'd make will probably depend on the number of hours he works. If he works a lot of hours, he'll make more money. If he works fewer hours, he'll make less money. But we don't know how many hours he might work in any given day. So we want to create an expression that will show that. So I'm going to pause now. I want you to try and create the expression. You can hit the pause button on the video, and in about a count of 3, I'm going to come back and I'm going to solve this, and you can check and see how your solution was in terms of creating the expression. Okay, hopefully you've created your expression by now, so I'm going to give you an example. So we know he makes $14 per hour. Whenever we look at a expression, when we're creating a real life one and we see a salary, we often get paid per hour. So usually that's going to sort of be the way that we'll set up our expression. So we know that he's going to make $14 for every hour that he works. Okay, that's constant. And that's going to be 14H, or 14 times H. And we know that no matter what happens every day, he's going to have $6 to pay. Now, what's really key, I think, for us to think about here is if he's paying $6, he's not making that money, he's actually losing that money. So unlike before where we saw some scenarios where an amount of money was added on, in this situation we're going to have to subtract that amount of money. So Sam's expression is going to be 14H, that's his amount of money that he's going to make at his job, minus the $6 that he's going to have to pay every day. Let's plug a random number in here. Let's say he works an 8-hour shift. So let's say he's going to, in an 8-hour shift, make $14 times 8, subtract $6. So that's going to equal 14 times 8, which is $112 minus the $6 pay, which means he is going to make $106 per day for an 8-hour shift. If that number changed to 7 hours or 6 hours or 10 hours, then obviously you would see that amount grow and increase. Okay, I think what's really important is that we keep in mind the idea between a constant and a variable. $14 is a constant because he makes $14 per hour. No matter how many hours, it doesn't change, right? The $6 is a constant, or the minus $6, because he's always got to pay that. If he works 1 hour, he's still got to pay that to go downtown to work. If he works 10 hours, he's still got to pay that to go downtown to work. The variable in this situation is the number of hours. We don't know in this particular situation how many hours he works, and those hours could change. So we could plug different numbers in there to tell us how much he would make for the number of hours he works. Let's do one more together. Again, I'll read the question and then you can pause the video. You can try and set it up yourself and solve it. And and we'll even give you a number this time and see if you can sort of solve for the evaluate the expression as well. But first, we want to set up the expression. So Neve gets a job working at Raptors games. She only gets paid $20 per game. That's important. But she gets $1 for every T-shirt she sells. So it's one of those concession situations where she has an incentive to try and sell as many T-shirts as she can, because for every T-shirt she sells, she'll make some money. Okay, so write an expression that describes Neve's salary per game. I'm going to pause the video, or you're going to pause the video. Okay, give it your best shot, and then I'm going to count to 3, and then you can come back and check and see how you did. Okay, we're back. So we know that Neve gets paid $20 per game. Okay, that's a constant. She's always going to get that $20, and we know that she gets $1 per T-shirt, but we don't know yet how to put this together. So she's always going to get 20. She's always going to get $1 per shirt. Let's use S as the variable. So 1S, or 1 times S, okay, is for the shirts. And let's add those together, because she's not losing any money in this deal. It's all getting into her. It's all money for her. So she's adding these two together. Okay, so let's try and solve this. So 1S plus 20 is going to be the amount. Let's say that she sells, it's Raptors game, 48 shirts. That's reasonable, right? A Raptors game, probably sell a lot more. So how would we put this in? If you want, you can pause right now, and then we'll evaluate this together. Okay, so she's going to still make that $20. That does not change. It's a constant. Plus $1, again, times the number of shirts. And in this case, the number of shirts is 48 shirts. Okay, so let's do our bed mass. Let's not forget bed mass here. That's going to equal $20 plus 1 times 48, which is $48. And then that's going to equal $68. So you make $68 for that day. Once again, the $20 is a constant because she always gets paid $20 per game, even if she sells 0 shirts. And the $1 is a constant. She always gets that $1 per shirt, whether she sells 1 or 100, she's still getting $1. The variable, of course, is going to be the shirt, and that's going to depend on how many she sells. So that's why we put the variable in there, so we'll be able to figure out what that is. Okay, hope this video was helpful. A lot of this comes down to language. Look for words like plus or minus or per. These things are all clues. They're all math clues about what operations you need to use. Okay, please keep in mind that most expressions will just have one variable at this point. Okay, but they could have one or multiple constants. Okay, so keep that in mind as well.